What's up, guys? So moving on to the next example for the long division of polynomials. So we got to take this polynomial over here, this negative 2x squared plus 3x cubed plus 4x plus 7, and divide it by 2x plus x squared. Now, again, what is the first step always when you're dividing polynomials? Make sure that the dividend and the divisor are arranged in a way where it's highest degree to lowest degree. So if we rewrite this, let's start with the divisor. The highest degree is 2, so we would rewrite this x squared first plus 2x. And then with the dividend, the highest degree is 3, so we rewrite the 3x cubed first. Next one is this negative 2x squared plus 4x plus 7. Alright, so we took the dividend, divisor, rearranged it highest degree to lowest degree, and now we could perform the division. Now, first step, see how many times can x squared go into 3x cubed. So 3x cubed, if we do it on the side here, divided by x squared, that gives us 3. And then x cubed divided by x squared, we subtract the exponents and we end up with x to the power 1, or just x. So 3x goes here. We take this 3x, multiply it by the divisor, so 3x times x squared is 3x cubed. 3x times 2x is positive 6x squared. And now, as we've been doing in the examples before, we subtract the dividend, we subtract this term from the dividend. So I like to put a bracket here and a negative sign. So 3x cubed minus 3x cubed is just 0. Negative 2x squared minus positive 6x squared, that ends up giving us negative 8x squared. And then bring down the 4x and the 7, so that ends up being plus 4x plus 7. Again, as I mentioned in the videos as well, the vertical subtraction, a lot of students make a lot of algebraic mistakes doing it this way. They don't fully distribute the negatives, so my suggestion is that you rewrite this on the side here, the dividend minus this whole expression, so it's easier for you to see and you minimize errors. Takes more time, but you have a higher chance of doing it correctly. So we rewrite the dividend as is, so 3x cubed minus 2x squared plus 4x plus 7. Then distribute this negative 1 inside the bracket, so we get negative 3x cubed minus 6x squared. And then this 3x cubed, negative 3x cubed, those cancel out. Negative 2x squared, negative 6x squared, those are like terms. We get negative 8x squared plus 4x plus 7. And that's what we ended up getting here. Next step, we find out how many times can x squared go into negative 8x squared. So if we do that on the side, negative 8x squared divided by x squared, well, the x squareds will just cancel out and we just end up with negative 8. So negative 8 goes here, take the negative 8, multiply by the divisor, so negative 8 times x squared is negative 8x squared, and then negative 8 times 2x is negative 16x. So when we subtract these two terms, negative 8x squared minus 8x squared, that nets out to 0. 4x minus 16x, that's the same as 4x plus 16x, which ends up giving us 20x. Bring the positive 7 down, and we end up with 20x plus 7. Again, doing this result on the side to make sure that this 20x plus 7 is correct. So we would distribute this negative 1 inside the bracket, so negative 8x squared plus 4x plus 7. Negative, negative, that ends up being positive 8x squared. Negative, negative, that ends up being plus 16x. So this nets out to 0. Then 4x plus 16x, that's 20x plus 7. Now, how many times does x squared plus 2x go into 20x plus 7? Or how many times, rather, does this x squared go into 20x? Well, it can't go in because the degree of the divisor is greater than the degree of what we're left with. So this here, this 20x plus 7, this ends up being our remainder. So to finish this off, I took this result and I wrote it in a division statement here. So basically the dividend is equal to the divisor of x squared plus 2x times the quotient of 3x minus 8 plus the remainder of 20x plus 7. Now, the thing that was different about this example versus the previous examples that we did was that the divisor had a degree of 2. Usually the divisors in the previous example had a degree of 1. But it doesn't matter. The process is the same. The only difference is going to be this remainder that we get. If you notice, it wasn't a constant. It had a degree of 1. But it still holds to the point that we made in the long division overview video, where the degree of the remainder always has to be the degree less than the degree of the divisor. Okay, so the degree of the remainder has to be less than the degree of the divisor. But no matter what you're dividing by, whether it's a degree of 1, 2, 3, whatever, the process is exactly the same. You're always taking the first term of your divisor and seeing how many times it goes into the first term of your remaining dividends. And you end up getting the same type of result.